1914. Canvas wings, pilots firing pistols into slipstream. 1944. Jets carve contrails. Today, stealth jets whisper to AI wingmen. Fighter power didn't jump, it stacked tiny hacks, a cam that timed bullets between prop blades, metal skins, swept wings, radar, missiles, and code. Each tweak rewired tactics and odds. In this sprint through a century, we'll track those small inventions that flipped air combat, one clever idea at a time, forever. In fighter aviation, the first worth anchoring to is the Vickers FB-5 gun bus, the first purpose-built fighter to see operational service. Designed by Archibald Reith, Archie, Low at Vickers, it first flew 17 July 1914 and entered service that November, created specifically to carry a forward gun and hunt other aircraft, rather than merely scout. Low, a Scottish-born pilot-engineer, educated in Cambridge's Mechanical Sciences Tripos, had been pushing Vickers toward an armed pusher layout, so the gunner up front had a clear, unobstructed field of fire. Practical, simple, and persuasive to skeptics still treating airplanes as fragile cameras with wings. The concept mattered quickly. On 14 February 1915, the Royal Flying Corps stood up No. 11 Squadron, the world's first unit formed expressly to destroy enemy aircraft, and it was equipped with gun buses, an institutional signal that air combat had become its own mission. Picture Low in 1913-14. Sketching duralumin and nacelle ideas while arguing that an airplane could be a weapon system, not a flying perch. That design choice, engine behind the crew, gun up front, didn't just solve the problem of firing through a prop. It reframed the airplane's job description and launched the fighter's evolutionary race.
1914-15. Purpose-built fighter appears. The Vickers FB-5 gun bus is the first fighter designed to hunt other aircraft, entering Royal Flying Corps service in November 1914. Its pusher layout put the Lewis gun up front with a clear arc of fire. By July 1915, No. 11 Squadron deployed as the first dedicated fighter unit. Early 1915, the deflector plate hack. French ace Roland Garros fitted steel wedges on his Moraine's propeller so a forward-firing gun could shoot through the arc, crude but proof that forward fire was decisive, setting up the next leap. Mid-1915, synchronizer and interrupter gear. A cam-linked mechanism times the gun to fire between prop blades on tractor aircraft, for example, the Fokker-Eindecker. This tiny mechanical fix turns nimble scouts into true single-seat fighters by letting the pilot aim the whole airplane. 1920s to 30s. Stressed skin metal airframes. All-metal monocoque, semi-monocoque construction puts the skin to work carrying loads, enabling cleaner monoplanes with retractable gear and variable pitch props, lighter, stronger, faster platforms heading into WW2. 1940 to 41. Night fighter radar. AI Mk4 becomes the first operational air-to-air radar, guiding bullfighters and mosquitoes to bombers in darkness. It adds an onboard sensor picture, range, and finding, so crews can prosecute unseen targets. 1944. The jet age. Germany fields the first operational jet fighter, the May 262, demonstrating sustained high subsonic speed and climb advantages of turbojets. Britain's Gloucester Meteor enters service and even chases V-1 flying bombs. 1950 to 53. Swept wings and transonic combat. In Korea, F-86 Sabres dueled MiG-15s. Swept wings delay shock and reduce drag near Mach 1, raising the envelope for guns, missile shots, and vertical maneuvers. 1953 to 55. Supersonic in level flight. The F-100 Super Sabre becomes the first production fighter to exceed Mach 1 in level flight, pairing thin swept wings with afterburning turbojets. Kinematic overmatch becomes a design target. Late 1950s to 60s, guided missiles and BVR. AIM-9 Sidewinder, IR homing, and AIM-7 Sparrow semi-active radar shift emphasis from guns to guided weapons. Radar scopes and beyond visual range shots enter standard tactics. 1965 to 67, Tactics Reboot. Early Vietnam missile performance disappoints. The ALT report overhauls training and systems, birthing Top Gun. Deception Plant Operation Bolo lures MiG-21s and restores kill ratios, showing doctrine can be a tech upgrade. Late 1950s to 80s, networks arrive. E-3 AWACS, first production in 1977, extends fighters' eyes, cueing long-range intercepts. In 1982 over Lebanon's Bekaa Valley, coordinated AWACS, SEAD, and fighter operations demonstrate the power of a networked air battle. 1972 forward, digital fly-by-wire. NASA's F8DF-BW proves fully electronic flight control on May 25, 1972. Later, the F-16 exploits relaxed static stability with computers keeping an agile, inherently unstable airframe inside the envelope. 1980s to 90s, stealth and precision. The F-117 brings operational low observable strike, first combat 1989, headline success in 1991, shrinking detection and engagement windows and reshaping how fighters and SAMs see each other. 2000s, AESA radars and 5G integration. AESA sets agile and low probability of intercept beams and simultaneous modes. The F-22 adds stealth plus supercruise, approximately Mach 1.5, and sensor fusion, while the F-35 goes further on fusion and sharing to see first, shoot first, share first. 2010 forward, smarter BVR missiles. Europe's MBDA Meteor uses a throttleable ramjet to keep energy into the end game, expanding the no-escape zone and rewarding networked mid-course updates. From a cam on a crankshaft to software-fused sensor pictures and ramjet missiles, fighter evolution is a chain of small, specific upgrades, each changing how pilots find, decide, and strike. Tiny pivots flipped air combat. In early 1915, French pilot Roland Garros flew with steel deflector plates bolted to his propeller so a forward-firing gun could shoot through the arc. Reckless, but it proved that true fighters needed a nose gun. Months later, the Germans fielded synchronizer interrupter gear on the Fokker Indecker, a cam system that timed bullets between spinning blades. A small mechanism triggered a big effect, the Fokker Scourge. World War II added a quiet superpower, the AI Mk4 Airborne Interception Radar. Mounted in night fighters by 1940-41, it let crews find bombers in darkness and cloud, turning night into hunting time. In Vietnam, hardware alone wasn't enough. The ALT report, 1968, exposed training and tactics gaps and led to the Navy Fighter Weapons School, Top Gun, which rebooted missile employment and debrief culture. And on January 2, 1967, Operation Bolo used deception, F-4s mimicking bombers on radio and route, to draw out MiG-21s and ambush them, a tactical plot twist that swung outcomes without new airframes. By 1982, the sky became a system. In the Bekaa Valley, Israel fused SEAD, fighters, UAVs, and AWACS queuing to shred Syrian SAMs and aircraft, proof that networks and doctrine could dominate as decisively as raw speed. The enabler behind that model? The E-3 AWACS, introduced in 1977, extended fighters' eyes and orchestrated the fight from hundreds of kilometers away.
Today's Edge mixes kinematics with cognition. F-22 remains the only fighter that routinely supercruises, cruising above Mach 1.5 without afterburner, so it can reposition fast without the fuel penalty. F-35 leans on sensor fusion, auto-merging IR, RF, and EW feeds, and sharing them across the force, so pilots see a single, intuitive picture first and act first. On the weapon side,
MBDA Meteor brought a throttleable ramjet BVRAAM into frontline service, first operational on Gripen in 2016, keeping endgame energy and expanding the no-escape zone. The next leap is crewed-uncrewed teaming. The U.S. Air Force advanced Anduril and General Atomics to build production-representative collaborative combat aircraft test articles, uncrewed wingmen meant to scout, jam, and shoot alongside F22 and F35. Australia's MQ-28 Ghostbat has already demoed E-7A-controlled missions with 2 live aircraft and a 3rd digital teammate in 2025, pointing to airborne command of loyal wingmen. 6th-gen projects formalize this family of systems. The U.S. NGAD, funded in financial year 2025, pairs a crewed platform with CCAs and advanced engines and sensors. Timelines are evolving, but the direction is clear. The UK, Japan, Italy GCAP plans a flight-ready stealth fighter by 2035. Europe's ECFAS targets a collaborative combat ecosystem around 2040. Trendlines are adaptive cycle engines, more range and thermal headroom, passive IRST for long-range emissions silent detection, and networked BVR missiles with sustained thrust and mid-course updates, software and links shaping as much as airframes.
A century of fighter evolution reads like a necklace of small beads, a cam that timed bullets, a skin that carried load, a wing that slipped past shock, a radar that painted the unseen, a missile that thought farther ahead, and software that stitched it all together. Each bead didn't just add speed or range, it changed behavior, how pilots searched, decided, and struck. Today's jets feel less like single machines and more like intelligent nodes, commanding sensors, effectors, and uncrewed teammates in a living network. That arc suggests the next decisive small thing won't look dramatic. A smarter sensor model, a cooler thermal budget, a more resilient link, an AI that anticipates instead of reacts. Which subtle upgrade flips the odds next? Will the best pilot be a mission commander directing a swarm, or a human-AI duo that simply sees the fight first? So, what do you think the future holds? Your turn. What era hits you hardest? The cam-timed guns of 1915? Radar that turned night into hunting ground? Or the stealth and supercruise leap? Drop your pick and the one detail that shocked you most. What should we unpack next? Baker Valley 82 as a play-by-play? A Meteor versus PL-15 BVR breakdown? Or how crewed-uncrewed teaming, CCAs, actually works in a real sortie? If this sprint through fighter evolution clicked, pass it to a friend who'll argue with you about it. And stick around. The end screen has a playlist of deep dives you'll like. See you in the comments. Bring your spiciest take.